he's the everybody is waiting to hear Dr. Biswal because he is like the Dronacharya of pellet industry and especially the mineralogy of iron ores. So we request Dr. Biswal to kindly share some of his findings. Particularly, my request to Dr. Biswal is that there are a lot of people here who are already familiar with pellets. So you may kindly give an impact of the practical aspects of the laboratory work done at IMMT. And also at your center, you might like to, this is a very useful center which you have mentioned, something about this. Of course, many people will feel how is it connected to pellets? So you have to explain that. Yeah, okay. Over to you, Dr. I'm not reading your full biodata. It is, everybody knows in this audience, 200 people know Dr. Biswal. So I'm sorry, I'm not reading it again.
Thank you. Thank you, Mr. Bhatnagar, for the introduction. Okay, already regarding the pellet, many discussion already has been happened, and particularly Shalia Sahab has given very nicely presentation about the problems of the pellet and with respect to also ore. I will highlight mostly, I will restrict to my presentation about the beneficiation of the lean and low grade ores. Next. Okay, that is a different types of ores are available in India. I will one of the example is the BMQ. Already my previous speaker about told that the Kudarmuk, the bended magnetite quartzite, which was the Kudarmuk plant has been established because of the environmental issue. 2005 it was closed, but another plant is there at Rajasthan, that is the Jindal Saw. Though it was small plant, it is around 1.2 million ton capacity of concentrate because the Rajasthan, as you know, the water scarcity, there is no additional plant could not able to be put up. But the main issue of iron ore is the hematite ore. The hematite ores, if you look after that my slides, because different industries, those are going for beneficiation and pelletization, their objectives are different. Some people are looking to the super grade pellet. Their input grade is 62.5 to enhance to 65-66%. Similarly, the lower grade were going for 63-64. They are taking 62-62.5 for beneficiation and pelletization. Like that, I have categorized the 5 categories. The last 2 categories, the low grade ore 55 to 55% Fe and a low grade ore from 45 to 55% Fe. This is the challenging task for the beneficiation as well as pelletization, because this low grade, these 2 categories containing the, if you see the mineralogy, mostly the growth height percentage is more and cowland percentage is more. That I will next I will tell you the how to tackle these things. Last is the lean grade ores, which is the existing slime. If you look after the Shell and Tata Steel particularly, they till now they are not doing beneficiation, they are doing the washings. And they have generating a lot of slimes at their mine sites. And those are doing the beneficiation, they are also generating a lot of tailings. Now the IBM has put up the cutoff grade is 45. Now this existing slimes and tailings containing the Fe content, even up to 60% Fe in these slimes and tailings are there. And lean grade ores, which now Dr. Kanan got told, because 2010, the BHQ, BHJ, and BGQ are called the ore. Earlier it was not called the ore. Now, at the present cost, because the iron ore cost has been increased, at present scenario, the beneficiation is more cost economical. Okay. Now I will tell about the blended magnetite course, which I have told India has the 10.789 billion tons of reserves is the BMQ, which is only utilized in Rajasthan. The remaining still it is there. Mostly it is available in Karnataka, Andhra Pradesh, Rajasthan, Tamil Nadu, and Goa. And Kudarmik beneficiation plant, which was set up, it is to produce 7.5 million tons from 22.5 million tons of feed. Because of the environmental issue, it has been closed. And Jindal Saw, which has set up in a BMQ basis at the Bhilwara, Rajasthan. But BMQ beneficiation easy. Only you have to look after the cost economic based on the Fe content and the liberation size. Otherwise, the beneficiation is not challenging. And the reserves of hematite, which is the measure we are utilizing for the steel production. We have India has 22.5 billion tons. This 22.5 billion tons has been estimated based on the 58 plus 58 Fe. Once they are estimating by the IBM, once go to 45 to 58, automatically the reserves will be improved. By addition of that, the BHQ, BHJ, once they add it, the reserves of the low and lean grade ore will improve in India. But when you are going for the beneficiation, that is mostly we have to do the mineralogical test, where we are lacking, particular for Indian industry sectors. We should understand that our ore contains, these are the mineral phases with a different percentage. One is magnetite and hematite. Your hematite ore, normally they don't believe the magnetite is there, but it creates the problem for beneficiation, particularly for those are using high intensity magnetite separator. That's why you have to take care before putting the ore to the high intensity magnetic separation. You have to use either limbs or MIMS to protect the AGMS. Otherwise, AGMS or WIMS will choke. Then hematite is there. That is we call the hematitic ore, but it has containing the goethite in a different form. One is called the vitreous goethite. Another is called aqueous goethite. We call the limonite. Apart from that, iron phase mineral. There are three major impurities are there. One is the kaolite. Kaolite nothing but aluminum silicate, gibbsite, aluminum oxide, and quartzite. But out of three impurities, mostly the kaolite dominates. It's mostly 90% is the kaolite, and kaolite has the swelling properties. When you put for beneficiation, the slurry viscosity goes up. And when Fe value decreases, the percentage of goethite and kaolite increases. And goethite by nature, it is fragile. And generation of fines below 100 microns increases after crushing and screening. It varies from 20 to 40%. The presence of kaolite increases the viscosity of a slurry due to the swelling properties. It makes negative impact in grinding, separation, filtration, as well as pelletization. And scrubbing, that's why we have developed a number of processes for different industries. But according to the commercial practice, we have to put the scrubbing at the beginning, and proper classification during the grinding play the vital role to control the beneficiation process. Already Sailesh have already narrated about this. Hence, the associated mineral phases decide the suitable process flow sheet for particular quality of ore. And the characterization, the latest facilities are available in different national laboratory and different and other laboratories. You may call the XRT, MLA, microcity. You can able to know what are the mineral phases are associated in our ore. What iron ore processing people are doing, if you take the mines, then the BHQ, they are separating a BHQ, they are separating, and they are taking particularly for the mines. The main objective is crushing and screening to generate the BF grade, DRI grade, center grade, and pellet grade. If it is high grade fines, they take it for the center purpose or pellet purpose. If it is a low grade fines, they are taking to the beneficiation plant to produce it. But those are very low grade, they are stockpiling at the site. After beneficiation, we are generating the tailings and high grade products. These are the I am giving the one of the proceed because the depending upon the feed material, the process flow sheet will be different. What Fe you are putting and what Fe you want. According to that, whatever unit operation I have shown you, that it may be changed. It is not a common process flow sheet for all works, but three things you have to give them more importance. The beginning, you have to by scrubbing technology, you have to remove the fines. And another thing, if you are going to pellet making, to control the blend number, the combination of a cyclone and that is the dairy screen, you may call the high frequency screen, should be there. And to reduce the below 45% Fe, you have to use the two-stage magnetic separation. So the tailing should be below 45. And now the tailing issue all industry is facing because the environmental Ministry of Environment is not allowing to go for the tailings. Now we are taking the step to make the filtration. After filtration, you can stockpile because of the clay minerals. Once you go below 45, the clay minerals is more. You have to make a conventional thickener, then followed by the that is the paste thickener. From paste thickener, you go for the pressure filter. The pressure filter, as present practice, the pressure is maximum. They are going to 12 to 13 bar. But now in my center, we have now brought 20 bar pressure filter in pilot scale to filtrate to make a cake. The cake you can stockpile at the site, then you can make the greenery of those clays. But when you are going below 55 grade, the conventional process which I have shown you, it may not be economical viable. Second thing, the lot of tailing generation and lot of challenging is common. That's why we have done this is the reduction roasting, because the main objective of reduction roasting is to convert from the goethite and hematite to magnetite. Once you convert the magnetite, then recovery will be easy, and further making the pelletization easy. These are the low grade one, the dumping below 55%, and this is the limonitic ore. This is the BHQ, BHJ, BGQ. BGQ means banded goethite quartzite, is only available in Rajasthan in the associated with BMQ, and this is the low grade slimes or tailings. These are the process we are putting the reduction roasting. So we have done the rotor clean. That's the number of technique you can use in other country people are practicing. Once it converted to the magnetite by using the low intensity magnetic separation, you can get the magnetite product. These are the color. Once you go for ROM and to changing to the reduction roasting, and then magnetic product looks like this. These are the process flow sheet. Once making the reduction, then you have to grind to its liberation size, then do the limbs, and then because it is easy to make a filter, because after reduction roasting you cannot require the pressure filter, both tailing as well as concentrate you can able to filter it. I am giving one example, BHQ, which contain around 47% Fe. This is the Karnataka. You can see after reduction we are able to take 72% yield with the 66 grade. And tailing containing around 11 to 12% Fe. And Odisha ore, which we have taken the 55% ore, we are able to recover 80% with the 65% Fe. So what are the advantages of this process? It is increases 30 to 50% extra yield compared to conventional process, increase the grade of the concentrate, reduce the grinding energy minimum 30% because once you are hitting it, it becomes cracking. Maximize the recovery of processed water by filtration of both concentrate and tailings. Handling of the reject is easy and it does not require tailing pond. It can be stockpiled on the surface. Efficiency of the process will be better because there is no clay effect in the slurry. Transportation through a pipeline is easy due to low viscosity of the slurry because of the absence of clay mineral. Easy to make pellet and reduce the 20 to 30% energy consumption in the pelletization process due to exothermic reaction for conversion from magnetite to hematite, improve the pellet quality from magnetite concentrate, reduce the consumption of ore per ton of production of concentrate to improve the conservation of iron ore resources. That's why we call the radical shift in iron ore industry once they adopt the reduction roasting process. We have recently make the techno-economic analysis of the process, taking the 55% iron ore. The cost of production, if you take the 2,000 rupees of raw material cost, taking to that, and 1,200 rupees is coming the processing cost of reduction. If all together we add it, the cost is coming 4,800 rupees. And this, because this is the magnetite concentrate and the market value is more, you can able to use it, which already, and if the government can give the incentive, what madam told that if you can incentive with respect to the ore cost as well as the some tax benefit to the industry, then industry can think it. Now we are one of the plant may come up. We are working on that 200 TPH plant at the Rairampur. We are planning to set up the reduction roasting process. Once go for reduction roasting process, the whatever pellet you can make, either you can use for blast furnace or DRI. And this is the greenery using the mining waste. After making the cake, you can do the green stockpile and making the green. My conclusion is the capital cost in beneficiation plant may be more, particularly for reduction roasting, but ROI within the year you can get back. The capital cost for magnetite concentrate pelletization plant will be less. The ore having more than 40% Fe can be utilized for reduction roasting. Same way, you can use also BH2, BHJ, and BG2 can be used to maximize the iron recovery in the reduction roasting process. Thank you.
Thank you. Fantastic. Sorry, just a moment.
Okay.
Yeah, so it's excellent presentation, and really speaking, you have Guru, and you have really cut down most of your slides. I'm sorry for that, but if you have all the slides, what we can do is, because there is so much gyan in your this thing, so we will add to your slides, and thank you very much.